Come with us to make a brief journey through time. May 8, 1980, a historic date. Do you know what happened that day? The 33rd World Health Assembly issued the following statement: the world and all its people have won freedom from smallpox. And well, maybe some people are asking themselves right now, what is smallpox? And that is understandable, seeing as it is the only infectious disease that has ever been eradicated, and young people may not be familiar with it. Smallpox is a contagious and serious disease characterized by distinctive skin rashes and fever, and although nowadays there are countless vaccines and surveillance programs for different diseases, it has not been possible to eradicate any others. But what exactly is eradication? Eradication is the permanent reduction to zero of the global incidence of a specific agent as a result of deliberate efforts, and it should not be confused with elimination or control. So now, let's come back to current times. March 11, 2020, another historical date. The World Health Organization declares COVID-19 as a global pandemic, and the pandemic, unfortunately, has not ended yet. Considering all this, we decided to establish a parallelism between both diseases and ask ourselves, taking into account the characteristics that made possible the eradication of smallpox, which could be the COVID-19 features that make it difficult to be potentially eradicable. We believe this question is relevant when it comes to vaccination because it opens the possibility of vaccines being regarded as a means to eradication, as it was the case with smallpox, and not only a means to control diseases. That is not to say that eradication has never been the goal behind the use of vaccines, but maybe the urgency to eradicate diseases has not been as pressing as it is now due to COVID-19 and the impact it has caused in the world, both as a sanitary and economical challenge.
In the next slides, we're going to talk about our methodology. In order to determine what makes the eradication of COVID-19 difficult, we perform a bibliographic research in different databases and sources, such as Google Scholar, PubMed, as you see on the screen, LeadCovid, MESH, CDC, and WHO, among others. For COVID-19, we wanted the most up-to-date information as possible, so articles published before November 3, 2020 were not considered. For smallpox, apart from the up-to-date articles, we needed information close to the time of eradication, so articles from that time were consulted too.
Now, we would like to show you some of the information that we collected on smallpox and COVID-19 on different levels. As for the virus features, one of the main differences is the genetic material, pDNA for Variola virus and RNA for SARS-CoV-2. Smallpox has an incubation period that ranges from 7 to 17 days, and infected people are not infectious during the incubation phase. However, the incubation period for COVID-19 ranges from 1 to 14 days, with people being able to transmit the virus up to 2 days before symptoms appear. Also, asymptomatic carriers of COVID-19 can transmit the virus, making it difficult to detect infected individuals. Meanwhile, there were no asymptomatic cases of smallpox transmission, which made infected people easier to isolate. Regarding immunity, to date, people who withdraw COVID-19 are believed to have antibodies for at least 11 months, while people with smallpox gain lifelong immunity. Finally, while smallpox is an exclusive disease of humans, COVID-19 has an animal reservoir. Smallpox could be easily diagnosed by looking at clinical manifestations. However, due to the presence of non-specific symptoms and asymptomatic people, RT-PCR is the gold standard technique to diagnose COVID-19. Unlike smallpox, most COVID-19 vaccines require 2 doses. Despite this difference, their efficacy compared to smallpox vaccines is similar, though it decreases with new variants. It is also important that COVID-19 vaccines are refrigerated. This was not necessary for smallpox vaccines. In addition, in smallpox, it was possible to vaccinate after exposure. However, due to the incubation time of COVID-19, vaccination as a prophylaxis is not recommended. Some studies have shown that after a successful vaccination against smallpox, subjects remain immune indefinitely and do not require booster vaccines. In the case of COVID-19, it is unknown how long the immunity due to vaccination will last. In 1967, the smallpox eradication program was guided by a comprehensive eradication plan, where case detection and outbreak containment measures, such as vaccination of close contacts, were used to interrupt the transmission. The COVID-19 eradication plan has not been drafted. For now, the strategy being carried out is mass vaccination in developed countries to combat it.
But from this information, which are the characteristics of COVID-19 that may result in a different eradication outcome compared to smallpox? First of all, the mutation rate of SARS-CoV-2 is much higher than that of variola virus. This leads to more variants, resulting in the loss of efficacy for vaccines. It also calls for the generation of modified vaccines, as it happens in the case of the flu. However, there is some hope, as the mutation rate of SARS-CoV-2 is lower than that of other viruses like influenza. In addition, the fact that asymptomatic COVID-19 patients and individuals in the incubation period can infect others, and the fact that it has an animal host, contribute to the viral spread. Moreover, it is not known for sure if having passed COVID-19 will provide immunity for life. It is important to highlight that COVID-19 cannot be detected simply by clinical observation, and diagnostic tools are required. This, in addition to having a certain cost, sometimes requires special personnel, laboratories, and certain time until the results are obtained, complicating the diagnosis in countries with fewer resources. In this sense, a program called ACT Accelerator has been developed, which is guaranteeing the provision of diagnostic tests to developing countries. In the case of COVID-19 vaccination, booster doses are required in most cases. This can become a limitation because there are people who may not show up for the second dose. In terms of distribution, COVID-19 vaccines must be stored in a freezer or refrigerator. This becomes an impediment, especially in low-income countries, as it can disrupt the cold chain. Another important feature is that in the case of COVID-19, it is not possible to vaccinate after exposure, so ring vaccination cannot be used. Ring vaccination in the case of smallpox made it possible to isolate outbreaks in those areas where the distribution of vaccines was insufficient. So it will be interesting to find a strategy that will allow doing the same in the case of COVID-19. Well, is there any approach currently being studied that reminds us of this? The answer is yes. Specifically, the use of neutralizing antibodies against SARS-CoV-2 has been shown to protect against viral infection, so it is a promising prophylactic strategy. Finally, World Health Organization has not come up with an eradication plan for COVID-19 yet. However, the COVAX initiative has been developed to ensure equitable access and distribution of vaccines. To conclude, although we don't know what the future holds, we have been able to find some characteristics of COVID-19 that give strength to the idea that it is not eradicable. These include the presence of an animal reservoir, the appearance of new variants, the presence of asymptomatic people and people in the incubation period that can infect, the inability to vaccinate post-exposure, and the uneven distribution of vaccines and diagnostic tools. Although these characteristics exist, we believe that there are some initiatives that can help us to get closer to eradication. Firstly, it may be interesting to dedicate resources to the development of passive immunization as a prophylaxis. This would allow us to be closer to ring vaccination, the strategy that made it possible to block the transmission of smallpox in countries with fewer resources. In addition, it is very important to invest in the globalization of the distribution of diagnostic tools, as well as of the interventions used to stop transmission. In this way, it is necessary for all countries to work together for a common goal since, if not, eradication is practically impossible.